In this video, we're going to go through how you can implement WebSockets within a Plotly Dash project so that you can get real-time updates for your dashboards rather than having to use a REST API and having to wait multiple seconds for an update. We can instead stream live updates to our dashboard and essentially go tick by tick. So we'll be building the dashboard that you see in front of you as an example, and there are two main elements. The first one here is the price of Bitcoin. So that's getting continually updated every 0.2 seconds or so. And then down here, we have an aggregated metric. So this is the number of Bitcoin trades that have taken place in the last minute on a rolling basis here. So you could think of this as a way to try and catch momentum in the market. If there are lots of trades, you might expect large price movements. It's just an example metric, but it does the job of showing us how we can implement it. And as you can see, these are all updating in very, very close to real time here. You can adjust the frequency to whatever you want. I left mine at about 200 milliseconds since I thought that was about fine. But with the methods I'm showing here, you could probably go down to about 50 milliseconds or so, and it would still work fine. We're using a direct WebSocket connection to Binance here. So I'm requesting the aggregated trades for Bitcoin USDT from Binance. I'm just using the aggregated version here, so the aggregated trade stream, because there'll be fewer updates and therefore it's easier to process the data if there's lots and lots of samples coming in. So we're taking in this data in real time here from a WebSocket, and we're saving that down into a SQLite database, streaming that down. So I'll show you here the process that's doing it. So this is downloading roughly, 4,000 trades a minute, as we can see from our dashboard over here. We can see approximately, 8,000 a minute now. That information is read into our dashboard here. We're just querying it from that local SQLite file, and we display that every 200 milliseconds here. So I'm going to show you how to implement that, how to deal with some concurrency problems, because we're accessing the same file with multiple different threads, and some neat tricks with Plotly Dash here to make it automatically update like this and draw a smooth update curve, rather than completely redrawing the graph, which is very computationally expensive and tends to not work for these lower update times like 1/10 of a second. So that's enough rambling from me. Let's go ahead and get started building this project. The whole thing's under 100 lines of code, so strap yourselves in and we'll get going here. So the first thing I'll do here is I'll just exit out of this dashboard here, otherwise it's going to confuse us later on. I'll also cancel these other two processes here. So for the first file we'll be working on here, you'll want to install a asynchronous version of the SQLite module. So pip install AIO SQLite. Basically, what this allows us to do is interact with our database in an asynchronous fashion. And with that, we can go ahead and open up our database Python file here. So I'm going to call mine data.py. This file is going to be responsible for grabbing data from the Binance WebSocket, saving it down to an SQLite file, and then in our Dash program later on, we'll be able to retrieve that data. So we'll get started and import some modules here. We'll start with async IO, which is going to be important for allowing us to use the WebSocket. We'll also import sys. That's going to be useful later on. We'll import SQLite3. This is the built-in SQLite Python module. And we'll also import our asynchronous SQLite module, as well as JSON here, because the type of data that we get back from the Binance WebSocket is in JSON format. So we need to initialize our database here. So if you go over here, we can see that we've got this main.db file. It's an SQLite file. We need to create something like that so that we can then save information down to it. That's fairly simple to do, so you can create a connection variable here. So connection is equal to SQLite3.connect And then just basically the name of the file here. So dot dash, I'll call mine data.db. That's just going to be a path to the file. So the dot here just stands for the current directory. If that doesn't work, you can always type in a full path here to the database directory that you want to save it in. Once we've got that going, we can create a cursor here. So cursor is equal to connection.cursor. This is going to allow us to execute our commands. And speaking of commands, that's what we want to be doing here. So the first command that I'm going to execute here in our cursor is I'm going to tell it if we have any trades already in there in the trades table, then I want it to just delete the trades table and start fresh. This is just going to fix any problems for us, and it means that that file that we have on disk doesn't get too big. Since we only care about the last 60 seconds of data anyway, we're perfectly safe to delete the data between runs of the program here. So I can run cursor.execute here. And then inside here, you want to run the command. These are just going to be regular SQL commands here. So drop table if exists trades. So we'll just get rid of this table if it happens to exist. And now that we've gotten rid of it, we want to recreate it. So cursor.execute. We want to make our new trades table here. I'll do the 3 quotes here so that we can have this over multiple lines. So create table trades. And what do we want this table to look like? Well, if we go to the Binance WebSocket documentation over here, we get all of this information, but we don't really need to save it all down. What I'm going to do is I'm going to save the unique ID here. That'll be really helpful in making sure that we actually get every single trade because they're ID'd sequentially. And so if we have 100 trades and they're all sequentially labeled, we know that we've actually got all of the trades and that we haven't lost any of them. So I'll save that. I'll save the price because we need that for our ticker. I'll save the quantity here. That could be useful if we wanted to do some metrics around how much volume was traded in the last amount of time. And I'll also save the time here. That way we can only aggregate the trades that happened in the last minute or last 2 minutes or whatever you like. This is the event time here, whereas this is the trade time. I'm going to be using the trade time since I only want to aggregate trades that have actually happened within the last X amount of time. So let's translate that into SQL here and create our table. So the first column is going to be ID, it's going to be an int, and this is going to be our primary key. We already know from Binance that this ID here is sequential and it's unique to every single trade. So we're not going to have any duplicates, and that's going to be fine to use as our primary key here. I'll also use the time, and that's also going to be an int. So the time is going to be represented by an integer. I believe Binance uses milliseconds since the epoch. We'll then fill in the quantity here, so quantity. That's also going to be an int. And then finally, we've got the price. That's going to be a float. So that's the schema for our table here. That's what it's going to look like on disk. I'm also going to create an index here. So that's going to be our third command. Create index time on the time column. What this is going to do is it's going to create an index on this time column that we have here. It's going to be called index time. That allows us to query much faster on this column. So later on, I'm going to be requesting all of the trades that happened in the last 60 seconds. So obviously, I'm going to be using the time column here. I'm going to be requesting all values with a time column above a certain number. And if I create this index, the database will fetch me answers way more quickly than if I didn't include it. In general, if you're going to be querying a column quite a lot, it's very helpful to make an index like this. After that, I'll do cursor.commit, make sure everything's committed to the database, everything's finalized, and then I'll do connection.close here. So that'll close this connection for the time being. We'll reopen it when we need to save something down. So let's run this program really quickly, see what happens. So yes, it tells me connection does not exist because I called my variable just con there. Again, it tells me that it's wrong. Just a variable naming issue here. Cursor has no attribute commit. Perhaps it's connection. There we go. Let's go check here if we open up our folder that it actually created that file. So you can see there's a data.db folder here, and it's 16.4 kilobytes in size, which must just be the default size allocated. I'll mention at this point that if you don't want to use an SQLite database like the one I'm using here, because it's not suitable for your purposes, you can follow pretty much the exact steps I'm showing here with something like a timescale DB or a Postgres DB. Either one of those systems will work just fine for what I'm doing here. It'll be pretty much exactly the same commands. The reason why I'm using SQLite in the video is that you can easily create and delete full databases just using Python. It's going to be the same on every platform. Whereas something like Postgres is a little bit harder to set up and requires specific instructions for each operating system and setup. So that's why I'm only covering SQLite. But if you have a significantly higher volume of data, or you need to do more queries per second, or you have multiple dashboards feeding off this information, then I'd highly recommend setting up something like a timescale DB. And I have a link in the description to show you how you can do that. So let's get back to our SQLite database here. And so far we've made the database. Now we actually need to populate it with stuff. And the way I'm going to do that is using async.io. So I'm going to create a asynchronous function here, and we'll call it save down. And it's going to take a URL. And that URL is going to be the WebSocket connection. So if I go over here to the Binance documentation, you'll be able to find a similar thing with whatever market socket you're using. It'll normally tell you an endpoint here. So for example, this is the base endpoint. And then if you want a single stream, you do /ws / the name of the stream. If you want multiple streams, so say you wanted multiple tickers, you could use this format instead. We're just going to be getting Bitcoin data in this video, so I'll copy this and I'll save the URL over here. So URL is going to be equal to this /ws /BTC USDT at ag_trade. So we want the aggregated trades for BTC USD. Again, all information considering this can be found in the documentation. So if we go over here, aggregate trade stream, we can see this is the format that we want to use. Okay, so let's open a connection to that WebSocket inside this function down here. So we've got our async def saved down, great. Now we need to fill it with our asynchronous functions here. So we'll use the context manager that comes with the WebSockets library. So async with connects URL as WebSocket. I don't think I actually imported this earlier on. No, I didn't. So it's from WebSockets import connect. WebSockets here is an external module you'll have to pip install if you don't already have it. Let's go down here again. So this context manager here gives us a really easy way to receive information from our WebSocket. All we have to do is something like the following. So we'll set a variable here. So I'll call mine data is equal to await WebSocket.receive. So at this point in the program, we'll hit this await here. And this lets Python know that it can go and do other tasks while it's waiting for a message to be received, which includes things like saving down data to the database. So I'll print the value of data here, and we'll let this thing run and see what happens. Okay, nothing happened there, and that's because we didn't actually run this function. So in order to run a async.io function like this, the easiest way to do it, if you've just got one to run, is to do async.io.run, the name of the function, so save down, any parameters, I'll pass in the URL here, and that should be good. So we'll let that run, and we should get at least one message here. So there we go. This is one individual Bitcoin USDT trade that's happened. And then the WebSocket closes and the function stops running because we only awaited the reception of just one piece of data here from the WebSocket. If we want to get all of the trades, we'll have to repeatedly do this. Now, an easy way to do that in Python is just to add a while true here. So essentially forever, we're going to stay in this loop. We're going to want to wait any incoming data. And then after we get that data, we want to print it out. So let's see what happens here. There we go. You can see we've got pretty much like hundreds and hundreds of trades coming in here. This number over here, this A number, is the trade number. You can see it's going by pretty quickly there. I timed it before and it was in the region of 4,000 to 8,000 trades per second happening on Binance here. And this is the aggregated trades, so there are quite a few unaggregated going on. We can quit this by using Control-C. You may have to use it twice, or it may take a second here to close the WebSocket properly. There we go, you can see it's complaining here about async IO being interrupted. So now we've got the data, we want to save it down to our database here. So let's have a check on the type of data that we're getting here. So print type data. I'll just put a break here, so it'll get one piece of data and then it'll break. You can see that this whole thing is actually a string, apparently. So we need to convert that into a dictionary. It very much looks like a Python dictionary, but it's as a string currently. So if we do something like data is equal to json.loads here, and then pass in data, that'll convert it back into a dictionary here. So if I let it run again, we can see this is now a dictionary, and therefore we can key in with any of these particular variables here. Okay, looks good to me. So what I'm going to do here is I'm going to create a list here called trades buffer, and it's going to be an empty list. And the reason I'm doing that is because I want to save down multiple trades at the same time. You saw just then how many trades were coming in, maybe 4,000 to 8,000 a minute. We don't want to be opening and closing a connection with the database that many times a minute. That's a lot of overhead, and it's likely to cause problems with the database, especially with SQLite. It does not handle concurrency quite as well as Timescale or Postgres do. And so to reduce the amount of times we're opening and closing that connection, every time we receive a trade, I'm going to add it to this trade buffer. And then when we have more than 10 trades saved up, we then save them down all at once. And that way we're only opening the connection a few hundred times a minute, which is still a lot, but it's a lot better than a few thousand times a minute. So on this trades buffer, I'm going to append the data that we want to keep here. So trades buffer dot append. What information do I want to save in here? Well, the information I want is I want the ID, which has the A here. So I'm just taking this directly from the Binance documentation here. So we want the ID, which is this one. We want the time of the trade, the price, and the quantity. So that's all I'm doing here. We're taking the ID, the time of the trade, so capital T, the quantity, which is a Q, and finally the price here. And I'm appending that as a tuple into this trades buffer. I'm using a tuple here as the data, well, it should be immutable, it shouldn't change. And that's the format that we need if we're going to save all of these down at the same time. I believe it needs to be a tuple or a list of tuples. So that's great, we've got our trades buffer here. And then if the number of trades in the trades buffer, so if the length of the trades buffer here is greater than 10, well, now we want to get down to business and we want to actually save this down to our database. The way we do that is with yet another context manager here. So it's async with AIO SQLite.connect, then the name of the database here. So I think I called mine data.db. Just give the same path that you gave it earlier in the file. Then we need a handle, so I'll call it db here. Again, this context manager, much like the one with the WebSocket over here, is going to handle connecting, disconnecting, making sure nothing goes horribly wrong. It just saves us having to manually open and close these connections and handle a lot of exceptions ourselves. Now, saving down this information is honestly pretty simple. All you have to do is await. So we want to stop here in the execution of this function until this command has executed here. But in the meantime, Python can do other things if it's just waiting. So await db.execute many. So we're going to be inserting multiple rows at once. So we're going to use execute many here. This takes in a query string, as we've seen before. So the query is going to be insert into the name of your table. I called mine trades earlier, so I'll just call it trades. We then need the columns in the order that you want to insert them. So the order that I've got up here is ID, time, quantity, and price. What do I want to insert into there? Well, I want to insert the values from this trade buffer here. So trade buffer. So values. And the way that you tell SQLite here that you want to insert them is use a question mark here. So it's just going to be 4 question marks or however many variables you've got. If you've got 5 variables or if you wanted to save all of that information down, you just need to pad this out with some more question marks. And obviously make sure you've got the data in this trades buffer here to back it up. Close out this triple string here and pass in the trades buffer. So that's how it's going to extract each one of these items from these tuples and insert them. After that, we'll await a db.commit. So we'll make sure that all of this information is being committed to the database. And that's us pretty much done here. I will wipe the trades buffer here. So we need to reset that back to an empty list after we've done the commit here. If I set this running, it should work here. So I'll print out a few things so that we can see what's happening. So I'll print data as we go along here. And then I suppose every 10 trades, I'll print writing to DB. Let's run it and see what happens. So it's complaining here that I've named my variable incorrectly. I'll get rid of this break while we're here. Get rid of this break here. It's complaining that I didn't name these right. So I called my variable data here. So the one that receives the trade data. But I'm indexing into it with X here. So I'll just replace these with data. And there we go. So that looks to me like it's working. It's going to flash horrendously. So if we scroll up here, we can see what's happening. So it got 10 trades, or at least 10 trades, and then wrote them down. It's worth inspecting them here just to make sure that we're getting every single trade. You wouldn't want to lose any packets, especially if this is an important metric that you're using to trade on. But it looks to me here like we're getting all of them, so that's good enough for me. And that's the first part of this dashboard sorted here. So we've got our data, we're saving it down to disk. You'll see this here keep flashing over and over again as it opens and closes the database and it writes to it. It's also worth noting at this point that there is a WebSocket extension to Dash here. If you go to the Dash extensions GitHub page, there is a WebSocket built into here, so you can use it within a Dash page itself. So you can have a WebSocket component. I think they have it in the documentation here. You can have a WebSocket component that directly sits inside Dash here. So you can see it sitting in the layout here of the app. So you can try using this instead of the approach here where we have an external database where we write stuff down to. The problem I had when I tried to implement this for this project was that lots of messages weren't being received, and there is an open issue about this currently, so maybe that'll be resolved by the time you see this video. I just wanted to highlight this here as an extra option. Although if you need to query then lots of data that you've received from this WebSocket, using a purpose-built database is definitely the way to go. So let's move on here to constructing the front end of this project. It really shouldn't take us too long now that we've got all the backend in place. So let's go over here and let's open up a front end file. So I'll call it just frontend.py. You'll want to install Dash before we get started here. So that'll just be pip install Dash. I'll also be using pandas and Dash bootstrap components here. So you'll want to install those as well. I'll just get everything imported here. So from dash import HTML, DCC, outputs, inputs, dash, and state. Always lots of imports whenever you do anything with Dash in my experience. So we'll import all of these as we go here. I won't do them all in one block because that'll be very boring. And we'll create a Dash app here. So app is just going to be called Dash. We'll create a new app from the outcome of this Dash function. We need to create a layout here. It's app.layout. We'll provide a containing div here. So html.div. That's going to contain everything. And then inside there, the child elements, I'll have a h1 element, .h1, so a main title. And that's going to contain my price ticker here. So ID is going to be price ticker. And that should be good enough for now. I'm also going to have an interval object, so dcc.interval. And what this allows us to do is trigger a callback on a regular interval. So ID is going to be update. And interval, well, I'll set that to a variable here, so I'll call it update frequency. And then I'll create that variable here. So update frequency. I'll set that to 1 second from now on. So this is in milliseconds over here. So whatever number you give it. And then I'll close out this layout div here. So we've got that. And then all we need for our bare bones Dash to run here is just if name is equal to main here. So if we're running this as a main Python file, we're not importing it. Then app.run server, let's set debug here equal to true so we can see what's going on. So that should work as just a super basic Dash here. So as you can see, this is nothing interesting. There's literally nothing being displayed here. So we'll close that out and build some more stuff. So what I'd like to do here is every time this interval ticks, I'd like to query our database, retrieve the last X trades or all the trades in the last 60 seconds, look at the most recent trade, what was the price, and then update our price ticker here with that price as the most recent prevailing price. To do that, we'll need to create a callback as is customary in Plotly Dash here. So at app.callback, the output here is going to be to this h1. So that's where we want to put the information. We want to put the information inside this h1, the ID of which is price ticker. And where do we want to insert it? Well, we want to insert it into the children of this h1. If you just put a string in there, it will display the string as a h1. The input here is just going to be this interval here, so update. And we don't really need an input variable here, but I'm just going to set it to n intervals. We don't really need that, but I don't think the callback works without it. So this is just a decorator here, this app.callback. We need a function for it to decorate. The function is going to be update data here. And it takes in this intervals here that we take in from this interval. So this n intervals is going to be the number of time that this has pulsed. So after 10 seconds, it'll return 10. After 20 seconds, it'll return 20, etc., etc. So intervals here. And at this point, we need to start connecting to our database here. So I'll go and import SQLite here. So import SQLite3 so that we can connect to the database. And we'll run a connection here. So connection is equal to SQLite3.connect. Then we'll just give the name of our database like before. So whatever you saved it to, just the full path. So it's data.db for me. We'll create a cursor here. And if you're wondering why I'm creating a new connection here every single time we want to update this, and I did the same thing when we were writing down the data before, when we were writing the data down to the database, I opened and closed the connection every single time. The reason for that is that SQLite isn't amazing with concurrency, so if multiple Python processes are trying to read and write to it at the same time, it really doesn't like that. And so what you can do is you can make sure to close the connection, and that will allow the other processes to connect during that period of time. And we can also add a timeout in here to tell it to wait a period of time. So if another process has locked the database, it will wait a couple of seconds, and during that time the database will become unlocked, and then this process can lock it, etc., etc. That's why I'm opening and closing all these connections here. It is quite a lot of overhead, but it's the price you pay for using something like SQLite and the convenience that it provides. So okay, here, let's go get some data. So we'll do data equals cursor.execute. And what command we want to put in here? Well, I'll just put a simple query in here for now. So we'll select all from trades. We'll order by time descending. So we want the most recent data at the top. And then I'll ask for a limit of 10. So the most recent 10 trades this query is going to ask for. And then I'll use .fetch all here to actually fetch me the data. And we'll print that out, so data. And I'll just return some random number here. So I'll return 456 just to make this callback happy because it expects a return here. So I'll run that and then usually have to open the dash page here before it works. So we can see here, it does seem to be requesting the data. It's getting this list of tuples here, which is exactly what we want. The most recent one here should be the latest trade. So this is 3.9. This is 3.8. I'm assuming this one's 3.7. So that looks all good to me. We should be able to now do something. So the price of the asset here, we had as the last element in this tuple here. So it's this last one. So in order to get that, we have to get the first tuple in this list and then the last element of that tuple, which is easy enough to do. So we'll go over here. And instead of returning that random number, well, we'll return data 0. So the first tuple. And then we want the last element, and there are 4 elements, so we'll index into 3 there. Let's run that. And open up our page. Let's do a Control R just to make sure that this is refreshed. And you can see this is already working, you know. We're receiving data from this WebSocket. Every second it's updating. If I want to, I can update this way more frequently without it breaking. So if I go over here, I'll change this to 200 milliseconds and give it a run. So we can see that's updating way quicker now, so that'll increase your anxiety there while you're trading. So that's all fine and dandy. We've actually gone ahead and fully implemented the WebSocket connection here. Now let's add in a graph just to show you how that works and how you can update graphs in real time. As looking at a ticker is quite nice, it's better than nothing, but we want to see some fancy charts here. So in order to create that here, let's make a graph object inside here. So it's irregular dash core components. That's what DCC stands for here. So dash core components dot graph. We'll set the ID here is equal to graph. And then we need to provide a figure object here. So the way this is going to work is we provide a default graph, and the default graph is not going to have any data in it at all. And then every time this callback gets triggered, we add an extra piece of data into that callback. So we add the most recent data onto that trace, and Plotly can figure out how to smoothly add that without having to awkwardly readjust the axes. So the way we create that default graph over here is we just create it as a regular Python dictionary, actually, with all the attributes that Plotly expects a figure to have. So default fig here is just going to be a regular old Python dictionary. So you can create it like this, or you can also just use regular Python dictionary syntax. I'm going to use this since it can be a little bit clearer what's going on. So there's a few things you'll want to pass in. I'm going to indent here because it can get a bit complicated. The first one here is going to be the data. So the data, as I said before, that's going to be completely blank. So we have a list here containing our traces. The first trace here is just going to be a dictionary, and we're basically just going to say that nothing's going on. So we've got on the x-axis here, we have nothing, and on the y-axis, we also have nothing. And then close out our brackets here. So that's good, we've told it there's no data, no need to bother with that. We can now give it some formatting information if we want. I'll put a little bit in here, we'll be revisiting it in a bit. So layout, well, layout is going to be another dictionary, so let's do some more indenting here. And we can provide information about the x and y axis, so let's say x-axis is equal to yet another dictionary, and we'll set the range in here. So this is just the default range for the x-axis. I don't think it's that important. It just affects the initial layout of the graph when you open up the dashboard. The y-axis here is also going to be a dictionary, and we'll set the range for that as well. I'll set that from 0 to 8,000 by default because I know that's sort of the average range we're looking at here. Close out this layout dictionary, and that should be good enough for now. We'll do some more styling a bit later to make it look better, but we don't need to bother with that for now. Let's go ahead and add our default fig in here, default fig. So that's our standard figure created. It's going to look pretty empty. Looks like I missed a comma off somewhere. Yeah, over here. So I'll run this. Let's go have a look at our graph, see what it looks like. So we can see the x-axis goes from -1 to 1 as before, and the y-axis here goes from 0 to 8,000. It's currently not doing anything because we haven't told it to update, and our ticker's still madly updating here. So, okay, let's add some data into our graph so that it's a bit more lively. I'll have to import a few more libraries here to get that to happen. So we'll import time, and we'll also import pandas. Actually, we don't need pandas, we only need time here. You could use pandas if you wanted to do some more sophisticated analysis. So you could convert this list of tuples here into a pandas data frame, do some analysis on it, and then spit out that number, whatever indicator you've calculated, back to your dashboard. But we don't need to do that. I'm only interested in the number of trades that have occurred, so I just need to count the number of tuples. So we'll have to change this query here slightly. So instead of select from trades ordered by time descending limit 10, we'll get rid of this limit here. And we'll instead query where the time column is greater than a certain value. So time from here is going to be that value. And I want that to be math.floor of time.time minus 60 times 1,000. So that seems a bit random. Why did I do that? Well, time.time gives you the current amount of seconds since the epoch time as a floating number. So if I just open up a Python terminal here, Python import time.time, it gives you this. So it gives you the number of seconds as a floating point number. What I'm doing is I'm then taking 60 seconds away from that. So I want what was the time 60 seconds ago. I then multiply that by 1,000 to get it in milliseconds. And then I round that down to the nearest millisecond. Because the column that we're querying is an integer, and so I want to use an integer when I'm querying it. I'll also import math here, otherwise that will error on me. So we're selecting all columns from trades. We need to have a where clause in here. So where time is greater than time from, so time underscore from. And I'll just insert that in there as an F string. This is safe to do because this time from here, we're just calculating it using the system clock. So it's perfectly safe to inject that into our query here. So this will give us all trades that happened in the last 60 seconds. From that, we can calculate the current price, so current price, that's just going to be this information here, but I'll write it as a variable to make it more explicit what it is. So data 0, 3, and we can also calculate the total trades. So total trades, well, that's just going to be the length of data. So however many tuples there are, that's all good. Okay, so we've got that information. Now we need to update the graph. The way we do that is, well, we need to provide another output here. So we've got the price. We also need to tell it to update the graph or to extend the graph. So we'll provide another output. The ID here is just going to be the graph. And the element that we want to change, that we want to add data to, is going to be extend data. Extend data. As far as I'm aware, this only really works for scatter graphs, but you can test on other kinds of graph yourself. Dash is, of course, compatible with all kinds of plotly graphs. So we've got two outputs here. The first one is going to be whatever data that we want to extend our graph with, and the last one's going to be the price. So I'll just insert the price here. Now, the format that we provide our response to extend the graph with is a little bit complicated. It comes in 3 different pieces, so I'll just type it out up here. So you've got the new data as a tuple. So we provide this whole thing as a tuple. The first section is going to be the new data. The second section is going to be the trace to add data to. So you can have multiple lines on a scatter graph, say if you're showing multiple symbols. You'll want to tell Plotly which trace to add it to. Now in our case, that's really simple. It's just the only trace on there. So it's going to be the 0th trace. And then the final point is the number of elements to keep. So you may have noticed in my earlier demonstration that as more points were being added, points were being removed from the back of the graph. This number here lets you control that. So let's go and write that on out. So the data you provide as a dictionary like we did earlier. So it's going to be a dictionary where we provide the list of X values. So I guess the value that I want to display here is the current time. So I want the current time and how many trades there were in the last 60 seconds. So the X-axis is going to be the current time, which is time.time. And then on the Y-axis, well, I just want that to be the total number of trades. So total trades. The second element here in this tuple is going to be, as I said before, the trace. So it's just 0. We want to add it to the only existing trace. And then the number of points to keep, I'll leave that at 100. And we should be good here. If I let this thing run. You may have to double click this here before it'll zoom into the right data. So something's not quite working out here. Let's go have a look. I think you need to wrap these inside double brackets for it to work. I imagine it's because it appends these to the end of the trace, so it needs them to be in list format. Let's see if that works. Yes, there we go. So we can see this is now being added, and every 200 milliseconds, or however long I set that for, this is getting updated. It looks like there are quite a lot of trades happening at the minute. It's normally about 4,000, but I guess the price of Bitcoin is moving up over the course of this video. So, yes, there are 20,000 trades every single second, and our mighty little SQL database here is keeping up with it, our SQLite database, which I guess shows you the power of these technologies. You don't necessarily need some massive database, like a timescale database, that you have to host on a cloud server. For the rest of this video, I'm going to neaten up this a little bit so it looks a bit nicer, but we've got the main concept at this point to implement into your own projects. Let's just check this here, see what's happening. It looks like it's still going, it's just there was a massive burst of trades apparently, so that they went down for quite a while. So, okay, let's get back to styling here. Let's close this down. I'm going to style the graph with a couple of things. So if we go back to our default figure here, we can get rid of the x-axis. So I'll do visible equals false. For me, it looked a bit weird when it was just scrolling across because it's showing the time in milliseconds and it just doesn't look very good to me visually. For me, this indicator is more of just a a trend thing. So you see, oh, the number of trades are going up, the number of trades are going down. There's been a big spike recently. So we don't really need to look at the x-axis, so I'll get rid of that. I'll also change a few things here. So the y-axis, I'll change the text color to be white, or the color of everything to be white. I'll do that because I'm going to use a dark background in a second. So I'll set the background here, so the paper background color. I'll set that to a hash value here. You can set this to whatever you like. But I'm going to use 2D, 2D, 2D. And I'll also set the plot background color to that value as well. So hash 2D, 2D, 2D. So this value represents the color on the plot itself, and this one is the surrounding space. So we've got that. Let's import a dark theme here. So we'll import those bootstrap components. So import dash bootstrap components as DBC. If you want to know which ones you can get, you can go to Boots Watch here, and all of these different themes you can pull just by saying their name. I'm going to be using Cyborg. So the way we implement that is we just go down here to where we create our app, and we set an external style sheet and just set that equal to dbc.themes.cyborg, all caps. Okay, so that's setting our style sheet here. Let's give it a run, see if everything works. Okay, so that's looking a little bit cooler, I think. We now just need to sort out our spacing. So this is all the way trapped in the corner here. It doesn't look amazing. So let's sort that out. We can do that using an inline style tag here. So within the H1, we can create a style tag. So style is going to be equal to, and then the dictionary here, we provide various CSS values. So text, align, I want it to be aligned in the center. And then we'll have some padding on the top and bottom. So padding top is going to be 120 pixels. These are just values that work for me on my screen. They might be slightly different on yours. Padding bottom is going to be equal to 40 pixels. So that's some quick styling here. If I let it run, this should be very similar to the example I showed you earlier. There we go. So you can now watch this to your heart's content and view the number of trades happening every minute on Binance for any pair that you want. It'd be fairly easy to implement multiple pairs or derive some other maybe more useful metric from this table. So I hope you enjoyed the video and you learned about how to architect these programs with WebSockets inside a Dash instance and how you can use a database to temporarily store that data and then query it and visualize it in Dash, how you can separate that into the two separate components so that each script can do the thing it's best at. As I mentioned earlier, SQLite is not the beefiest of database systems, so if you're doing this at very, very high input levels here, so if you've got thousands and thousands of data points being constantly read and written into the database, it may struggle and crash, and in that case, you'll want to use a solution like Timescale. Again, I'll leave video links in the description to how you can set that up.